Alright, welcome back. So in this video, we will be talking about importing libraries. So as I mentioned in the previous video, it has been explained, right, in the Python tutorials, but I shall provide a bit of a, um, something to refresh your mind, I suppose. So we can see there, yeah, I already provided all the definitions. So Pandas is essentially a software library written for the Python programming language for data manipulation and analysis. In particular, it offers data structure and operations for manipulating numerical tables and time series. That is, of course, an open source software, right? So we can use it in our project. So specifically for Python, yeah. Okay, so and then we have Numpy, right? Numpy is essentially a library for the Python programming language as well. Um, yeah, essentially to support, it has support for large multi-dimensional arrays, matrices, along with a large collection of high-level mathematical functions to operate on those arrays, right? So we shall be doing a lot of some mathematical functions as well. It is actually a very common. Both pandas and NumPy are a very common library, right, for Python data science stuff. It's one of the most popular ones essentially. And then we have Scikit-Learn. So it is a software machine learning library, right, for the Python programming language. It's free, and it features various classification, regression, and clustering algorithms, including SVM, random forest, gradient boosting, k-means, and other stuff essentially. So we will be using those, yeah, and those are free. And I actually provided a bit of a sample code, right? The code that we actually use in the implementation. So essentially, we import pandas as PD, numpy as np. So we can actually do this to shorten the notation, right, in our code. So we can just write like pd dot something to use pandas and np dot something to use numpy, right? And then for sklearn itself, for the uh, performance evaluation comparison, right, we will be using the ROC curve, the area under ROC curve, right, the accuracy, position, recall, F1. So we'll be using those. And for the classification algorithms, we'll be using logistic regression, which is available on sklearn, decision tree, SVM, right, and random forest, LDA, linear discriminant analysis, QDA, quadratic discriminant analysis. Um, yeah, essentially those. Yeah, we have a lot of other stuff as well. So essentially these are yeah, uh, some algorithms that we import as well. And this is actually some of the functions that we will be using from Sklearn to actually help us do a performance evaluation as well. So we have the mean squared error, we have precision recall F score support, so this can display the all those three. We have the feature scaling stuff right here, standardization, right? We have cross validation, so like we'll be doing cross validations for the algorithms as well. And last but not least, for train task split, we don't have to do it manually, so it has a built-in function as well for the train task split data, right? So yeah, these are the ones, the libraries we will be using, will be important in our um, project essentially.